Welcome to clickmyproject.com. Our product title is Design and Development of an Efficient Multi-Level DC to AC Traction Inverter for Railway Transportation Electrification. Next we see about abstract. An inverter is basically a converter that converts DC to AC power. Inverter circuits can be very complex, so the objective of this method is to present some of the inner working of inverters without getting lost in some of the fine details. In this present work of a newly voltage balancing neutral point clamped inverter had been developed. This output is utilized in the transportation industry to adopt the multi-level inverter based propulsion systems. In this proposed work, space vector pulse width modulation technique is used. This technique is very efficient and eliminate unwanted harmonics from the output voltage over than other PWM technique. This PWM method is easy to implement and a very few reckoning. This inverter module having back-to-back clamped diode voltage modulation operation thus achieve a voltage regulation and high efficiency at any loading condition. Multi-level inverters are very popular in medium voltage power conversion such as power motor drives, power conditioning devices, renewable energy generation and distribution. Because of voltage stress is less on switching devices, better harmonic reduction, low switching frequency and less switching losses. Due to the presence of these elements, the inverter can operate normally and the voltage stress is shared uniformly to all switching devices, and capacitors voltage should be controlled, thus result over abundance of switching states. The cogency and expectancy results of the proposed topology is verified by simulation. That inverter design is helped to reduce the harmonic is normal, and then result was analysis in MATLAB simulating model. Next we see about flow of our product. In this proposed work we achieve the drawbacks of existing system and compare to the result with the existing method. In this proposed 3 base 6 switch full bridge inverter is used to reduce the harmonic level. The space vector pulse width modulation technique is very helpful to making the switching pulse with better perform output. This design can create high power quality for a given number of semiconductor devices than the fundamental topologies alone due to a multiplying effect of the number of levels. The space vector pulse width modulation technique gives the better pulse with low frequency range. The switches withstand also high frequency range and also the switching losses is reduced. Comparing to the classic 4 level topologies, it has less number of components and complexity, and this is the flow diagram of our product. Here this is input source. The input source is a DC source and that DC source is fed to the inverter block, and this inverter block convert the DC to AC through the clamping diodes and MOSFET switches. After that the conversion of DC to AC, that AC supply is fed to the load. Here we using space vector pulse width modulation technique. This block generate the pulses and this pulse is fed to the each MOSFET switches, and then the inverters start to convert the DC to AC conversion. The load may be a AC load. In our product here using traction control AC loads. Next we see about running process of our product. Before that, first we know about some advantages of multi-level inverters. The multi-level inverters produce common mode voltage, reducing the stress of the motor and don't damage the motor. Second one, multi-level inverters can draw input current with low distortion. third one, the multi-level inverter can operate at both fundamental switching frequencies, that are higher switching frequency and lower switching frequency. It should be noted that the lower switching frequency means lower switching losses and higher efficiency is achieved. And last one is reduced harmonic distortion. That means selective harmonic elimination technique along with the multi-level topology results the total harmonic distortion becomes low in the output waveform without using any filtering circuits. In our product, totally 3 legs is used, each legs having 6 MOSFET switches and 4 pairs of clamping diodes and 5 input DC sources. The DC source, clamping diodes and MOSFET switches are nested with neutral point clamped inverter topology, and each input DC source consists 400 volt DC supply, and the corresponding output waveform is getting from the scope in this product, and the load is a RLC load. Next we see about the output waveform of corresponding product, and first one is the output current waveform, and next one is output 3 base voltage waveform. This is the 3 base output voltage waveform. The range is around 1600 voltage, and next one is base voltage of our product. The first one is VAN, second one is VBN, and third one is VCN. And next one is line voltages. The line voltages is measured from line between A and B. And next one is total harmonic distortion. This is the total harmonic distortion waveform. Here shown the value of total harmonic distortion in percentage. That value is 23.03 percentage. Compared to the conventional method, that percentage is very less, and this is the efficient of our product. And overall advantages and applications is very efficient compared to the conventional methods.